My name is Peter Wahl. I'm the product manager for encryption, key, and secrets management here at Oracle in the Oracle Database Security Group. Today we will be talking about transparent data encryption and Oracle Key Vault. And let me see how I can progress. Okay, so this is, of course, part of the Oracle Maximum Security Architecture. And as you can see, we have many components that help you address several attack vectors into the Oracle database. And today we will be talking about the two elements that you see in the middle on the lower end. So we will be talking about transparent data encryption and Oracle Key Vault. And as I said, we have many more things. So this builds for a long time. And as I said, we will be focusing on transparent data encryption and Key Vault. Oh, yeah, I think we're done now. So how does it work? So we have access controls in the database, plenty, right? From database vault, virtual private database, label security, all those elements, all those products and features. Keep your data secure when a user or an application comes in through the database. And now if somebody bypasses the database and goes against the data files that contain your table spaces, then they can theoretically pretty easy get to the clear text data that is stored in those table spaces. And when 10GR2 came out, that was a few months before PCI came out with their first data security requirements for the financial sector. We introduced TDE column encryption. TDE column encryption was in the beginning used to encrypt credit card number columns or social security or driver license numbers, addresses, first names, last names, all these things. But it wasn't, there were a few limitations. And at the time when Exadata came out, we needed to make this a little smoother, the integration of encryption with all the new features that came with Exadata. So we invented tablespace encryption, where we encrypt the entire tablespace. And if you use tablespace encryption, there are no application changes anymore. So we encrypt on the block level, which means that we don't even know if that block contains a table or an index. We just encrypt the blocks where we see ones and zeros, and we don't know which database object is that block. And it has a very low performance impact. We allow you to online and offline encrypt table spaces. That's also something that was backported to really old database versions. It has built-in key management, either with local wallets or Oracle Key Vault. And it integrates with everything else that the database can do. So we're running on Exadata. We work with compression. You can encrypt your table spaces in ASM, in DataGuard, Golden Gate, Data Pump, multi-tenant, you name it. And as I said earlier, we don't really care which application is running in that database because there are no application changes. TDE is very much alive, even though it's a pretty old product. As I said, it came first out in 10GR2, and tablespace encryption was introduced in 11GR2. So here on that slide, you see how we try to make it better, faster, easier to implement, and easier to use. What we have backported from Oracle Database 19 all the way to 12.1 and all the way to 11GR2 and 12.1 is that you can offline encrypt existing table spaces. And you can also define that if a table space is encrypted without the encryption syntax, we still encrypt it. So that comes handy when you install an older application that creates table spaces. While it installs, the database will automatically encrypt those table spaces, right? Without the installation script knowing about it, but your table spaces would be encrypted. In Oracle Database 12.2, we allowed you to encrypt and rekey the table spaces online, which means there is no application downtime. We added the ARIA, seed, and the Russian ghost encryption algorithms. And we had a new feature that allows you to hide the key store password. So that could be the wallet password or the password into OKV from the administer key management command line interface. In Oracle Database 18, we introduced the per PDB key store. And finally, after many years of struggle, we removed the dependency of TDE from environment variables because they were error prone and not so stable as you wish. So the wallet root and the TDE configuration parameter replaced the dependency on signal.aura. If those static configuration parameters are set, the entries in SQL.aura are ignored. So you can leave them in, but we wouldn't read them anymore. Oracle Database 18c allows you to bring your own key into the TDE wallet. We encrypt sensitive data in the data dictionary tables. I would like to highlight that this one feature, the encrypt sensitive data in data dictionary tables, belongs to the minimum security architecture that we have. The minimum security architecture in Oracle lists all those features and functions that don't cost you anything. So, for example, virtual private database, fine-grained auditing, those security features come with your enterprise edition, so you don't have to pay for them. And if you would like to encrypt sensitive data in data dictionary tables, this requires a complete TDE setup, either with a wallet or with OKV, but no ASO license. For a migration from on-premise to the Oracle Cloud or backwards, Arman introduced the capability to encrypt a backup that was taken from a clear text database and restore and duplicate it in OCI as encrypted. Or if you would like to go back, then you can restore and duplicate as decrypted if you don't have a TDE license for your on-premise database. That makes sure that there are no violations. And you can do this without any extra gymnastics, right? You just tell Arman to decrypt the backup when it comes from OCI, or you encrypt the backup when it comes from your on-premise database and goes into OCI. With Oracle Database 19, we allowed you to change the database default algorithm, which is AES by default. Now in 19c, you can change this to AES 192 and AES 256, but only if you make this setting before you create your first key or before you create a key store. And that capability was backported to 11GR2, 12.1, 12.2, and 18c. So in all those databases, if you start using TDE, if you haven't used TDE yet, and you would like to start using TDE, and you would like your tablespaces to be encrypted by default to AES 256, and you want to use offline encryption to AES 256, then you would have to apply a patch that gives you that capability to change the default algorithm if you do that before you activate TDE. In Oracle Database 19, we also allow you to encrypt the system sysocs temp and undo tablespaces. I will talk about this a little bit later. The encrypt lob locator is an extension to the encrypt sensitive data in the data dictionary tables. So again, this doesn't require a TDE license, but a complete functioning TDE setup. And only recently, because the per PDB key store that was introduced in Oracle Database 18c was only available on engineered systems and in Oracle Cloud Infrastructure. Now, with that patch that I'm listing there under Oracle Database 19c, this is available everywhere for everyone. So a few limitations. Everyone means customers with an enterprise edition. And everywhere means it's on-premise and in OCI. If your database is run in another cloud, no, you can't do that. It's not licensed. In Oracle Database 21c, we finally added database command rules to allow you to control who can administer key management commands. And another very fine feature is that DBCA, the Database Configuration Assistant, understands TDE commands. So you can create encrypted databases with DBCA. So when your database is born, it's encrypted already. Key management. As I mentioned earlier, key management is built into TDE. You can either use the Oracle wallet, which is a password encrypted container on your database host, or with Oracle Key Vault. We have a two-tier key architecture. We have data encryption keys in the database that are managed by TDE. There's nothing that you have to worry about. And those data encryption keys that encrypt your payload, they encrypt the columns and they encrypt your table spaces. Those keys are encrypted with a master key that lives outside of the database, in Key Vault or in the encrypted wallet. From the very beginning in TDE, we allowed you to rotate the master key, and that only decrypts the data encryption key with the old key and re-encrypts them with a new key. So that basically allows you to do rekey operations without downtime, and that, of course, is still true. Starting with Oracle Database 12.2, you can also rekey your data encryption key, but certainly that goes through the entire table space. So there you would not do that. You can do it in an online fashion, but you don't want to do it at the busiest time of your business when your databases are screaming for power. So that was this one. When we came out, when we designed Key Vault, we basically learned from the limitations that our customers experienced when they did key management with HSMs. In the early days when TDE came out, our customers had 1, 2, maybe 10 databases encrypted and only credit card numbers. There you may or may not be happy with an HSM, but if now our customers have internal mandates that tells them every single database needs to be encrypted as soon as it's born. So from the beginning, everything will be encrypted. Now, if you have, like our large customers, they have anywhere between 8,000 and 12,000 databases. You cannot put this into an HSM anymore. You need something that scales and that is designed to support all the extra gymnastics that you can do with an Oracle database. So if you have an Exadata system with hundreds of busy pluggable databases, they issue key management commands against an HSM or against OKV hundreds per second. So you need a system that can keep up with this load. And there cannot be downtime, right? The downtime of, or the availability requirements or expectations for key management systems are exponentially higher than the availability targets that you have for a database. Because it's a single point where your encryption keys are stored. So this system can never go down. It always needs to be awake. There are also security mandates come out, like, for example, PCI, I believe, that no longer allows you to keep the encryption keys anywhere near your encrypted data on the same server. So you need to move your keys off your encrypted database into something else, and that something else would better be OKV, Oracle Key Vault. Of course, if you keep your keys in your wallets, if you can do that, it's very hard to manage if you have thousands of databases, right? You need to create those wallets, you need to protect them, maintain them, make sure they are not lost, make sure you don't lose the wallet passwords, because otherwise there is no backdoor in TDE. We cannot help you recover from a lost wallet or from a lost wallet password. wallets don't scale, and that is why we came up with OKV. If you decide to use an HSM to provide key management for your encrypted databases, you're on your own. You have to talk. If anything fails, if you have any kind of problems, we would send you back to the HSM vendors, because they make the claim it works. They do the testing, documentation, troubleshooting, everything. We don't. So we certainly help you when you have problems or questions with OKV, but not with HSMs. They are no longer supported. When I came back to product management 3 years ago, one of my first duties was to remove any reference to HSM from the Oracle documentation, to make it clear that we no longer support them. So Oracle Key Vault. Oracle Key Vault can be installed in a cluster, and I will get to that in a moment. A cluster is, as you can see, the horizontal arrows here in this picture, they depict synchronous replication, and the blue arrows depict asynchronous replication. So the horizontal pairs of OKV servers are read-write pairs. They are updated synchronously. If you do a set key operation on your on one database, then we will give you your database prompt back when this key has been replicated to a second OKV, meaning we guarantee that your key that OKV generated on behalf of your database is at least present on 2 OKV nodes. So if one goes down, we always have a copy of that key on some other OKV server. And a few moments later, that key will be present everywhere on all 4 OKV nodes in this picture. And not only do we integrate with all of these products that we listed around that cluster, right? So we encrypt, you know that you can encrypt Golden Gate trail files. We provide key management for it. You can encrypt the MySQL database. We provide key management for it. What I have seen, it is brand new. I've seen it myself only just before this presentation, is that we provide key management to the ZFS storage appliance, which is built into the public cloud appliance, right? So if this is encrypted, you can easily migrate from the local key store that is in the ZFS into OKV. And the C and Java SDK that we introduced with Oracle Key Vault 21 allows you to basically rewrite very, very easily any application that has the need to process secrets or keys of any kind to integrate with OKV. Right? There are a few calls that you need to add into your code, and then passwords or secrets or encryption keys are stored and retrieved from OKV as they are needed. And we have a C SDK and a Java SDK, and we also have a RESTful services that has the same components that we can do in C and Java. It's easier for scripting. If you're not a developer like me, I wouldn't know what to do with the C and Java SDK, but I can easily handle the RESTful API. OKV is definitely enterprise ready. We have really large deployments of OKV inside Oracle OCI in our cloud infrastructure. We have one business unit that creates databases for the GBU, so for our global business units. So they have over 20,000 databases in OCI running, and they're encrypted, of course, and key managed in multiple 8-node Key Vault clusters that are distributed across the globe. And believe me, they have direct access to development and to me. If something breaks, then they will call us and we will fix it. So what you get is basically what we learned from them. And they demanded a cluster, we gave it to them, and now you can certainly benefit from the cluster technology. What it gives you is that you have access to your encryption keys everywhere, local where you need it, with global consistency, because your keys are copied everywhere. With OKV 21.1, we also introduced the integration with Microsoft Active Directory. So now you can manage your users that are the administrators of OKV in Active Directory. You can also deploy an OKV image in your OCI tenancy from the OCI marketplace. And we reduced that deployment time from 28 down to 10 minutes. That's very significant. When we released OKV 21.3. So 21.3 deploys in only 10 minutes in your tenancy, and the older versions unfortunately took 28 minutes. So we basically came up with a third use case, right? The first use case that everybody knows OKV for is online key management for your TDE-enabled databases. Then the other thing that we always offered was to upload and download a wallet. If you do not want your databases to talk to OKV directly, you should at minimum upload the TDE wallet into OKV, which gives you another backup copy. Your database doesn't know about the fact that you uploaded the wallet into OKV. So your databases continue to talk to the wallet, but you have a backup copy in case you forget the password, the wallet is corrupted, you have a backup copy in OKV that is available immediately. And what we introduced in 21 is secrets management, online secrets management, where you register a password, a private key, whatever it is, whatever is valuable and needs protection. You can upload it into OKV and fetch it on demand. How do we keep OKV secure? So there's only a very small number of users who can access OKV through the web interface. We have a system administrator, a key administrator, and an auditor role. Those are the only 3 administrators that have access to the web interface from designated IP addresses. We also have a support user and a root user in OKV. The support user is the only one who can log in via SSH, and then the only thing that the support user can do is log in as switch user to root, and from there you can apply patches and do your things, whatever you need to do. In normal operations, we ask you to disable SSH and not let anyone in. The keyboard internally uses Oracle Transparent Data Encryption to encrypt everything that we store in Key Vault. We have database vault, access control rules, we have virtual private database, and we implement unified auditing to audit everything that we do. You can run OKV in FIPS mode, and we give you quarterly bundle patches that update everything, that apply the latest operating system errata. We update the Oracle database to the latest release update, and we introduce new features, fix customer bugs. And so you should please always keep up to date, at least with every second OKV release, with every second release update. So maybe not upgrade OKV every 3 months, but every 6 months minimum. Okay, so let me see. So as I mentioned earlier, Oracle Key Vault has been purpose-built to work with TDE-enabled databases. So whatever you throw at it, it's a business case that we know already. If you have your RAC instances, or if you have RAC-enabled data guard, this would be pretty complicated with any other third-party key manager. Oracle Key Vault was designed to work for those use cases. So if you have a RAC primary and a RAC standby database, if you do a rekey operation on one of your primary RAC nodes, that key will be available to every other participating instance of that data guard setup. So there is no downtime anymore. There is no need to copy wallets around. If you set up OKV correctly, and if you have a distributed data center where one data center contains your primary database, the other data center contains your standby database, you would stretch a read-write pair of OKV across your data center. And the key that is created on behalf of the primary database in one OKV will be replicated to the OKV in your standby database and will be available to the standby database before the standby database even needs it. So there is no case that you have to copy a wallet around, restart the MRP. That's all not necessary anymore. It's transparent. OKV makes TDE more transparent. If you need to clone PDBs from one container to the other, we allow you to change the ownership of encryption keys in OKV so that the the endpoint that belongs to your source container database has access to the encryption keys of your incoming PDB. And it will be completely transparent. OKV is integrated with the Zero Data Loss Recovery appliance. If you would like to reinitiate your if you like to rebuild cloud databases from a backup that was taken by ZDLRA, it will be encrypted and the key is stored in OKV. Right, so we make sure that everything is encrypted, no keys get lost. They are stored in an on-premise OKV cluster. I mentioned earlier that when you use Golden Gate, we can provide key management to the encrypted trail files. This also is important because if you encrypt the trail files without key vault, it's wallet-based. If you rekey on one side, if you generate a new key on your extract side of this equation, your replication process will fail because it doesn't know that new key. So you have to copy that wallet over to the replication side and restart the replication process. If this is again put into a multi-node OKV cluster, the key would be available on your receiving side before it even knows it needs one. Right? It's again completely transparent and no changes. Password management with Key Vault. I mentioned this earlier. If you have maintenance scripts, for example, that run every night, every weekend, they need a database account into your database. What we allow you to do is put this password into what we call a secure external password store. The secure external password store is a wallet on your server. If you have thousands of databases with hundreds of maintenance scripts running every week, every night, you need to maintain those wallets. And if you change your password, you have to change the password in the database and in the wallet. Now, if you upload your password into OKV, then we can automate the password change process. The password can be generated so that it's to be used only once. The password is very, very strong because humans don't have to remember it. So there are so many benefits that you get from retrieving a database account password out of OKV because everything can be automated. You can write a script that generates a new password every day after the script was running. You generate a new password that we change in the database, that we upload into OKV, and that we use the next morning when your script runs. And when your script is done, we again change the password. And so this whole script can be automated and written once, and then you forget it and you have new passwords every day. If you have hybrid database cloud deployments, so you have your primary database on-premise and your standby database in OKV, in OCI, for example, then you can extend your on-premise OKV cluster with OKV nodes that came in from the OCI marketplace. So now we have the read-write pairs stretched from on-premise into OCI. Right? If your primary database on-premise generates a new key in OKV on-prem, that key will be replicated to the OKV and OCI, and there will be available for the standby database when it uses it. I talked about the read-write nodes. So when you build an OKV cluster, you install 2 standalone OKVs and you pair them. And that gives you the first read-write pair, right? The big fat arrow between them is synchronous replication. So though node 1 and node 2 is a read-write pair. If one node goes down, the other one can no longer replicate, and that is why this becomes a read-only node. Meaning we serve your databases, they don't suffer from a downtime, but we cannot replicate. And because we cannot replicate, we don't allow you to create anything new in OKV. So that is why a single node of a read-write pair is always a read-only node. Now, if you stretch these nodes across data centers, as I mentioned earlier, in parallel to your DataGuard standby, your DataGuard databases, and you would like to extend your cluster, you add a third node. This becomes a read-only node, which will be updated with the content from node 1 and node 2. Then you build another node that also will be updated by node 1 and node 2, and then you pair those and you have 2 read-write pairs. Which means that your primary database in data center 1 will always find one node it can talk to, right? Even if you take one node down for upgrading, it will always find a node that belongs to a read-write pair and can upgrade, can set a new key in this node, and this key will be replicated from node 3 to node 4. So here node 3 goes down for an upgrade. Node 4 becomes a read-only node. Your databases can talk to node 1 and node 2. It's a read-write pair, everything is good. We have continuous read-write availability if you have a 4-node cluster. Then after a couple of minutes, node 3 comes back, you pair it again, and your cluster is back in order. We designed, in OKV 21, we completely redesigned the user interface. So it directly gives you, this is the homepage. If you log into OKV, you get the numbers. How many keys do I have? How many users, user groups, all these things. You get the statistics, the vital data of your OKV is on your homepage, including the alerts on top. If you click on one of the little circles in the lower third of this screen, it will take you to the report, and you will immediately see which keys have been created most recently. They are sorted by time, so you don't see the keys that are 5 years old. You see the keys that were generated in the last 5 minutes. So this is very, very useful. And it is, it's designed for large loads. So if you use OKV a couple of years for thousands of databases, you will get to millions of keys, thousands of endpoints, hundreds of wallets. So this OKV has been designed to handle the big numbers. We don't want you to install anything in OKV because it's a hardened appliance. Whenever we give you a patch every 3 months, we expect OKV to be in a known state, right? That is why we have external monitoring through SNMP. And we also have RESTful commands that allow you to monitor OKV. So if you would like to know your downtime or your uptime, you can simply issue a RESTful service command and you will get what you need. A new feature that was also introduced in OKV 21.2 or 3 was the availability to add the ZFS storage appliance as a backup target for your OKV external backups. It doesn't make sense to create an internal backup in OKV when you have a cluster. Only external backups are useful when you have an OKV cluster. And that backup is only needed when you lose the entire cluster. So if all your 4 OKV nodes, or all the 16 OKV nodes that you can put in a cluster, if all of them die at the same time, then you can start rebuilding your cluster from this backup. Otherwise, if a node in your cluster disappears, then the other surviving nodes will take over. The databases will be updated with the information that node 1 and node 2 remain a read-write pair, but node 3 is a read-only node because node 4 disappeared. So every couple minutes, the configuration file for OKV on your database machines will be updated by the OKV cluster, telling your databases the latest topology changes. If you add nodes to it, if you remove nodes from it, your databases will know about it and will act accordingly. As I mentioned earlier, you can use the C and Java SDK to change any application that you have that uses or that can be enhanced with the KMIP interface to use OKV for key and secrets management. The DBMS crypto package is still used by many customers. Unfortunately, there is a documented weakness with DBMS crypto from the very first day when we introduced it, and that is the lack of key management. So now with OKV 21, you can manage the DBMS crypto keys in OKV. So finally, we provide key management for DBMS crypto. That's something that people have been waiting for 20 years. Now we have it. So that's a pretty big deal, I think. We have a persistent cache. The persistent, there are 2 caches in OKV. There is the in-memory cache and the persistent cache. The persistent cache is on your database machine. It's an encrypted file that is created, maintained, and protected by OKV. It contains the most recent master keys, which means that if OKV disappears from your network because you have a network outage, it's not your cluster that's missing, but nobody can reach your cluster. That's when the persistent cache comes in. The default lifetime of the persistent cache is 24 hours. It can be extended. I set it sometimes to 72 hours to give me enough time to upgrade my cluster. And it certainly helps to reduce the load on an OKV cluster during peak times, right? Because you can set your databases to talk to the persistent cache first and then talk to OKV if the key has expired. There are 2 modes of an encrypted password of a persistent cache. It either takes the same password that you use when you install the OKV client, or it can be protected by a randomly generated password of the database. The database generates a random password and applies this to the persistent cache. Of course, when your database goes down, the persistent cache needs to be rebuilt, but the use case of the persistent cache is not to cover database bounces. The use case is to cover key vault bounces. So whenever your key vault bounces, that persistent cache is not in question, right? And the database protected persistent cache that is encrypted with a random password provides a high level of security, because even if that wallet is stolen and somebody tries to get the keys out of it, nobody knows that password except the database, only for the current session. So after the database goes down, that password is lost. We know that many customers of us have a strong requirement that everything they do needs to hang off an HSM. So HSMs are not fit to provide key management to thousands of databases. That is why we give you the option to put a key vault between your encrypted databases and your HSM. And that what the HSM does, it protects the TDE implementation in OKV. So of course, the TDE implementation inside OKV is wallet-based. We have an auto-open wallet so that when the instance comes up, it doesn't prompt you for a wallet password. Nobody has access into OKV SSH access into OKV is expected to be turned off at all times. So nobody can get in. We can use an auto open wallet so that the database, which is encrypted, can start up without human intervention. Now, what do we do when you implement root of trust? We delete the auto open wallet. We create a new wallet with a randomly generated password. This password is stored in a file. The file is sent to the HSM. It's encrypted with a key and sent back to OKV. So the only thing that we store on disk in OKV is an encrypted password file. And if you would like to start OKV, and OKV cannot open the wallet of its TDE implementation because we don't have access to the HSM, we cannot get the password file decrypted, we don't have access to the password, we cannot open the wallet, we cannot open TDE, the database cannot start up, OKV doesn't work. So this comes into play when you virtualize OKV. When you run OKV in VirtualBox, in Oracle VM, in VMware, somebody theoretically could take that those disks that represent your OKV, a rogue virtualization administrator could theoretically copy the disk files onto a memory stick, take it home, and then poke around in OKV for a long time and maybe get to something. Now, if that OKV loses connection to the HSM, it will not start up. So even if it's stolen, if somebody carries out the server out of your data center with the OKV server on it, it will not start because it loses connection to the HSM. And that's it. It was a little quick because I wanted to give you a few minutes for questions and answers. Maybe if you have any questions, feel free to ask.
Well, Peter, actually, I do have a question, actually, two questions.
Mm-hmm.
So on OKV and secrets, is it possible to migrate your make store keys that you use to set up your auto logins over to OKV when you use the make store utility?
Yes, I mean, you can upload all wallets into OKV.
Okay.
And from all those wallets, the strength of uploading wallets into OKV is that OKV understands the content. So that's a very important additional feature.
All right. And Wundong is how to deal with SSL expiration in an OKV cluster.
That is one of the reasons why I recommended to you to really keep current on OKV upgrades, because in OKV 18, and it was backported to 12.2010, we allow you to rotate certificates with a single push of a button in OKV without database downtime.
And Collins is asking, is a test environment required in an OKV implementation?
Is a test environment required? I don't understand that question, sorry. I mean, do you mean if you need to practice?
Oh, yeah.
Yeah, so if that's your question, if you need to practice, why not? I mean, it's always good because encryption keys are very sensitive, right? If you lose them, your database is lost. I would, if I were a customer, I would definitely install a little OKV cluster, maybe 2 or 4 nodes in a virtual environment, and then practice upgrading, practice onboarding, see how it works with RAG and data guard and all these things. So I would definitely practice and get a feel for it, but it's not mandatory, because if you follow the documentation, it should be clear what needs to be done. And And you can go from there. You can automatically onboard all your databases. You can write a RESTful script that goes through all your database servers and onboards them automatically. And when you come back the next morning, all your databases are in OKV, theoretically. It needs to be fine-tuned, of course.
All right, in the chat, Windom has 2 data centers. One is primary, another one is DR. Do I need to have one OKV cluster for each data center or one big stretch OKV cluster spanning to both data centers?
Yes, what we recommend you do, if you would like to have continuous read availability for your databases, you would install one OKV pair in parallel to your databases, right? So you would stretch an OKV cluster, one read-write pair across your data centers. If you would like to have continuous read-write availability, then you would install 2 read-write pairs in parallel to your data guard setup and make them one pair. So you have a 4-node cluster consisting of 2 read-write pairs, and each read-write pair is installed in parallel across your data centers in parallel to your data guard setup.
For primary site, how many nodes are recommended? 2, 3, or more?
For all of you who don't know me, I live a mile away from a military airport. And when they fly through my backyard, I can hear you and you can't hear me. So that is why I had to go on mute for a moment. Continue to my previous question. For primary site, how many nodes are recommended? That depends. If, as I said earlier, if you would like to have continuous read availability, you make one cluster with 2 nodes, one read-write pair. If you would like to have continuous read-write availability, you would install a 4-node cluster or bigger, depending on how many data centers you have, how your databases are deployed. I can certainly help you with, if you have more than 2 data centers, that gets a little bit more interesting. We can work on this deployment model together if you want.
All right. And Collins has a question on subdividing an OKV environment recommended to prevent outage to all apps once there's a problem with OKV.
Well, if there is a problem with OKV, then the other nodes take over, right? If one OKV dies for whatever reason, a hard disk failure, something physical that cannot be easily fixed, the surviving nodes will provide key management and secrets management services to your databases. And you can either see if you can repair the damaged OKV and bring it back into your cluster, or if that's not possible, you install a fresh OKV and bring that fresh installed OKV into your cluster. It will be updated by your surviving nodes, and a few moments later, you have your old 4-node cluster back. So there's basically having an outage is pretty much impossible if you have a 4-node cluster. If we think about how often do computers die? Right? I can answer that question from my own experience. My computer died 4 weeks ago after 5 years. And if you have 4 of them, then yeah, that number spreads a little bit. And I wouldn't, yeah, I mean, if I were a customer, I would use a 4-node cluster or more, and then there's nothing to worry about in terms of key management.
What if the issue is related? All right. What if the issue is related to certificates expiring, as an example?
Okay, so I think that certificates are like Christmas. You know exactly when Christmas comes, but then still people tend to miss the date and go panic shopping a day before. So that's how you, oh, my certificates expire tomorrow, help. So what we do is we added the certificate expiration into the OKV alerts. If you look at the OKV alerts daily, you will not miss it. Further, with the later OKV releases, you can rotate your certificates without downtime. You push a button in OKV. What that button does, it generates new certificates, pushes them out to the clients. And when all clients have received the new certificate, the server will switch to use the new one. There is nothing for you to do. Everything happens automatically. Now, if you missed the date and your certificates expire, that's a case, that's time to file a service request. Because that requires open heart surgery on OKV, and you don't want to do that yourself. You need Oracle support to help you with this. So what I'm pushing for in one of the next OKV releases, if the expiration date of your certificates comes really close, let's say within 5 or 10 days, I will fight with my developers to, once you logged in into the management interface of OKV and the certificate expiration is less than 2 weeks away, you will get only one page with 2 buttons. It says, take care of your certificates. And then you have a button, okay, yes, I will do that. Or you have a button, no, and then we will not let you go anywhere, because this needs to be taken care of very quickly, very urgently. Hybrid setup, the only architecture available for XRCC. XRCC is an on-premise deployment, right? XRCC is an Exadata system on-premise, and we are working on ironing out the last things in the automated workflows that happen in XRCC to work with an on-premise OKV cluster. Though there is no hybrid setup, it's all on-premise. OKV and your XRCC database are on-premise. If you look at the autonomous database on XRCC, that also is an on-premise deployment. And there, OKV is already fully integrated into the deployment screens, right? So if you go through the deployment of your autonomous database on XRCC, you will come to a page where it says, what's the IP address of your OKV cluster? And from that moment on, the autonomous database is automatically onboarded into OKV, into your on-premise OKV cluster. And as I said, we are working on getting this deep integration into XRCC. And at one point in the not so distant future, you will be able to do the same thing what you can do with the autonomous database.
All right, I got one more question for you, Peter.
Mm-hmm.
And this is on TDE for online table space encryption, or any table space encryption for that matter.
Mm-hmm.
Is there a method to destroy the old data, overwrite the sectors on the disk after it is encrypted?
We do that automatically. We do that automatically. If you look at the alert logs of your database, it will tell you that we automatically zero out the old table spaces before we delete them.
Okay.
It is documented in the alert log.
Okay. And that's it for my questions. And Peter, I should have introduced you at the beginning of this, but for some reason my brain started going fuzzy. I apologize. Thank you very much. I am going to be cross-posting this to YouTube, and we will, if we can come up with more questions, we'll be doing this again. Thank you very much, Peter.
Yep, thank you. You're welcome. My pleasure. Goodbye.
All right, bye-bye.
Bye.